Swayam Prabha. Digital India. Educated India.
Hello and welcome to Geographic Information System. We'll in this module, as I said, we would look at basic operations, which taking off from the module 5. I did explain some of the operations, and my TA Prakash did explain some very basic things about QGIS. But now I would take it forward, explain each and every aspects of how do you actually edit, what are the different errors that may occur, how do you correct those errors, and what are the different things that you have to look at when you are looking at the edit tool basically. So why I am very specific about the edit tool is that when you start looking at your data, you will be looking at each and every aspect of the editing of a vector layer, because any incorrect attribute incorrect geometry can lead to lot of issues when you are looking at the entire GIS data. So this editing of this attribute is extremely important. So we'll look at editing of this geometry is extremely important. So we'll look at each and every aspect of why and how this is important, and why and it is necessary, and how do we do it. Okay, so this is more of a practice class. So in case if you guys are having a system in front of you, or if you are looking it in a system rather than your mobile phones, so you can parallelly start looking at it. So I would suggest you start looking at it, so it would be very useful in understanding the concepts that I have taught till now. Okay, so in today's class we will look at basic editing of the data that is acquired, procedures in integrated data analysis. I have done many of those, but I'll again take it forward. So introduction to editing, creating any vector layers in any GIS software, tools in a GIS software, some of the different tools we have already discussed some, but some of the other tools that are required I'll take it forward. Okay, so before we start, very important thing that we have to look at is how do we maintain a logical consistency in creating a vector database or any of the data models. Very important thing that you have to think. Okay, you can go to the field, collect all the data, extremely accurate, etc., and get it here, put it in the database, etc. That's fine, fair enough. But when you are looking at the database, your database has to have certain logical consistency. Without logical consistency, your data or your database may not really sound existing in the real world, because whenever you are actually creating a data model, it is actually to mimic the real world. If you do not have a logical consistency in your database, then your data model is not equivalent to a real world, and the very purpose of using a GIS system to represent a real world fails. Okay, so the logical consistency is extremely important in terms of how well a data model can explain the real world features. So data model is measured for basic editing through various measures. That is, if there are errors, if there are editing issues that come across whenever you are having a data model, that is the first thing that we will look at. The most important errors that we look at is two. One is the common vertex. Line, ends and the corner have the same vertex. Okay, ends of a line and a corner of a line, or a point that is ending the corner of a line, have the same vertex or not. If it is dangling, then you will have that is the error. Okay, so then you have a boundary. Adjacent polygons are overlapping, but do they share the same boundary? So even if they are overlapping, so they should have the same boundary instead of two different polygons overlapping, something like this. You have two polygons and it will be something like this. Instead, it should be something on one on another, or have a single boundary, not even one another. Okay, a very good example was again by Professor Price. When you look at it, avoiding dangle, let's say that you have a road that is represented by this line segment, these are two intersections, and there is another road which was supposed to be here, where this is an intersection here, is misrepresented here. This is one of the errors that you find it in your data. So that logical consistency should be there. So the first thing is, go to the edit mode and correct this error. This particular point has to be brought into this particular point. That is, you will correct the topology. The horizontal line intersects the vertical one, creating 3 different lines. So you will have 4 intersections, 1, 2, 3, 4 then. Okay. So once you put in the data, all geometry, first look at data detailedly. Without looking at data, without looking at these errors, you will not be able to correct any data that is there, or any information that is put out, you cannot certify that is correct. Okay. In order to look at validated data, first thing is correct the errors in the database. Look at the logical consistency in the database. Such errors has to be removed. Okay. Then there is something called a snap tolerance. When I say snapping, it means that minimum distance between the vertex at which they are considered to be identical. Okay. So when you are looking at this, there is a particular line segment A and there is a particular line segment B. Okay. So you have the same node here, which means that these two are actually closer. So that means that when for example, when you are looking at snap, it means to say that when you are drawing this particular line, digitizing this line, when you use snap, it correctly sits on this line instead of sitting it somewhere. If you are digitizing, you may even stop your line till here. Okay. I mean, you may stop your line till this point. See, if this is your original line that you have already digitized, if there is one original line like this, okay, now you are digitizing another road which is actually supposed to join here, you may stop here, right? So instead, if you use snap, what it does is it looks at minimum tolerance and it will locate whether these both are same points. If it's same point, it will snap to this point, making it the same common intersection. That is what is called snap tolerance. Snap tolerance is normally looking at the which are the things that are identical. Okay. So that's also the work of the snap tool. We'll see that in the further slides. So and the other problem, as I said, is adjacent polygons. So if you see here, this is one polygon. Okay. If we look at this polygon, this is one polygon. Now there is another, if I draw the same polygon, I have one polygon like this. Now there is another polygon which is representing the other land. So what normally when we digitize happens is something like this. Okay, this cannot be something like this. Let me erase this, let me do it in different form. So this is one polygon, let me take a different color. So if the same polygon follows the same structure, okay, fine. So these are two different polygons representing two different quantities on the earth's surface, but having the same boundary. Now because of your digitization, maybe various issues, you may have both of them in the different maps or different reference things. So you get this like this, but they should have a common line here, okay, common boundary. That is one of the issues when you are looking at logical consistency, which has to be corrected. We will look at this also, how do we correct it in our further slides. Okay. So the first, let me introduce you to the editor toolbar, and now from now onwards I will stick on to QGIS. I am not going it with any other software because QGIS is easily accessible to many. Those who do not have any GIS software can easily download QGIS, whereas other proprietary software, if you guys have an access to it, your institution provides an access. Many of the software also has student access for certain time, you can always download it. But if you guys do not have an access to the full version, the proprietary version, I would suggest you to download a free and open source software like QGIS. But most of these menus remain same, so you don't need to worry. Most of the representation also is same, and always it would remain same. Okay. So when you look at, this is the editor toolbar. Okay, when you, and these are some of the tools that I have added by myself for my analysis. So don't worry much about this. This is a Google Earth tool, and this is a the map tool, that is your OpenStreetMap tool, to access the OpenStreetMaps. And you can OpenStreetMap is a wealth of data that is already there. So you can even extract all the entire set of data that is already there on OpenStreetMap and utilize it for your analysis. So when you look at the editor toolbar, it has different sections. For example, the first section here, where you can see a single yellow pencil. Okay, so that is nothing but a toggle editing. If it is off, unclicked, then it means your data, whatever your data is there, you cannot edit it. You cannot do any changes for that, even if there is error in its boundary, its line, or there is a point that is the extra point that you have added. But if you click on it and it is an edit mode, you can use it to edit your polygon features. Okay, then you have sketching tools. These are the tools which are used for certain issues. For example, this is a move feature that is being used. I have not mentioned it here. It is a move feature, and there are different sketching features. There is a add feature here. Then you have save. Once you have edited it, you can even save. Then you have cut and delete features. You can cut a particular feature and make it, if there is a line and you want to represent those lines in different ways, so you can cut that feature and make it a 2 feature. So this is cut and this is delete, in case you want to delete a particular feature, maybe an error that has occurred, so you can cut it and delete that part. Copy paste also is there as normal. Then you have labels. To label that particular feature, particular vector, you can label it as necessary and as supposedly you need. Okay, then you have a meta search. So this is very good thing in your most of the GIS softwares. You can understand what do you mean by that particular layer, what are the information about that layer. Then the most important part is Python. So most of the software has access to Python programming. So once you have this, you can start coding you have your Python either in any of the environments that can be installed. So once you have installed, you can start even looking at all of the, take just modules and use it for your analysis the way you need. So that is about the editor toolbar. Okay, so then as I said, snapping is extremely important. But in QGIS, snapping doesn't come as it is. If you look at ArcGIS, snapping is just a drop down menu, maybe from your where the editing is there, you can just start snapping from there itself. But when you look at QGIS, you have to enable it via settings, option, digitizing, and enable snapping. So once you have enabled snapping, you get a menu in here just below your in your QGIS window or editing window, digitizing window. Okay, so if someone asks me why do you need snapping, I have already previously explained. In case a part of a line segment has already been created, okay, where I know what is the starting point and ending point and has been created, snap ensures the new digitized line which you are actually digitizing. When snapping is turned on, your pointer will snap to edges or vertex near it. So it will just go and set it instead of sitting at centimeters away or based on the units measurement away from that particular point. So it will snap to that point. So which means it will give you an extremely accurate. Snapping can be done to a vertex, can be done to a segment, can be done to both vertex and segment the way you need. Okay, so that is how snapping works. Then the saving part is how do you save a digitized layer. You can save a selected layer, you can even roll back in case there are some errors. You can for all layers you can save. If you have multiple layers you are trying to edit in the same overlaying all the layers, you want to correct some of the issues that may have occurred, so you can do it and save all layers together or save a particular layer only, and that's how you can save a digitized layer. Okay, then is the feature editing. See, for example, I have created a feature. This is one of the administrative boundaries that I have extracted from an Google Earth map. So now it can be created manually or can have multiple templates. For example, feature editing, it is a polygon editing. This is a point editing that I have. So there is two things. When you click here and say you want to do the feature is polygon, add feature is polygon, then the polygon editing will come up. If it is add feature is point, then the point editing will come up. So this is about the feature editing. So once you have turned this on, it means it will give you all the values that you can edit. Okay, this is about the feature editing. Okay, so you can have multiple templates, you can add, you can change all of these issues. If there are errors, correct these errors. Okay, there is another tool called as node tool. This will be very useful in terms for you to correct whatever the errors that may have happened in your when you are digitizing. For example, this is your node. Okay, please be very I mean, when you look at this particular node, look at this part. Okay, when I look at it, see this particular node, I have missed one node in between this node, which has to be and the segment has to be something like this. So now once you have activated this particular node, okay, this node tool here. So now what you will do is that you will double click on this node. Okay, once the node is activated, you can click here and then come back here. Okay, that's what I have done here. Fine. So what it does, it creates another node here and brings the line segment to that point. That is why the node tool has been is used, so that you can add nodes, delete nodes, and create whatever. If there is error, you can correct those errors in your digitized layers. Okay, so and then move a feature. This is also extremely good aspect in terms of any of the GIS software. For example, this is one of the features that you have. Okay, and for example, if this feature by mistake when you are digitizing may have sat across in your database, something like this, okay, connecting this particular vertex here. So what you will do with this move feature, you will click on this vertex and you will move this particular feature here wherever it is supposed to be. That is why you use a move feature aspect in any of the GIS software. Then you have delete feature. You can delete a feature. For example, if as I said, I want to digitize it newly, I don't want to move it or put it in inaccurate position, so I want to delete it, or if there is some error, I want to delete it. So I just click on this feature and it will show which are the vertex has to be deleted, and from that vertex this feature can be deleted. Okay, the next thing is attributes. So how do you open an attributes? For example, I have all these layers here. Okay, if you are able to see, these are the this first layer, second layer, this is a third layer, this is a polygon layer, and this is a line layer, and this is a point layer. Yes, yeah. So when we have these layers, if you want to look at this, just right click on this and you can see open attribute. Most of the GIS software have the same way. Right click on that and you can see open attribute table. Okay, once you have opened the attribute table, it looks something like this. Okay, this is an attribute table. So if you look at it, it says that I have imported it from a OSM map. So you have OSM ID, OSM type is away, it admin level is 1, boundary is administrative boundary, it's a government office, name is bush collectors, and barrier is wall. These are the attribute information that is there. Okay, now for example, if it had certain it also has, I don't know, it's not showing it here, it also has X and Y location. Okay, maybe I have not completed the entire attribute table. So if I have completed the entire attribute table, it is X and Y location, so you can even calculate what is the area of this particular attribute. Okay, so just by using different operations here. So this is how the attribute table can be accessed. So now if in this attribute table, if I want to, let's say if I want to edit this attribute table, you have to click on this. So it gives you editing of attribute table. So you can add, delete any row or any columns, you can add or correct any data that is not that is incorrectly saved, and do such operations once you have toggled edited it. So you should be extremely careful. Then you have save editing, where once you have edited it, if you in case you want to save it, so you can toggle it, so it saves whatever editing that has been done in the last few hours or minutes. So this is add or delete features. It means to say that it is, if you want to add a feature in this context, so you can add it. There is select and deselect features that is there here. Okay, there is pan, copy and paste. This is for panning for the entire database. This is copying and this is pasting features. Okay, the next tool that we are looking at here is new field and field calculator. When I am looking at this new field and new field calculator, for example, you have a lot of attributes in your entire sheet, let us say entire database. Now with those attributes, if you want to compute certain things or compute certain issues or compute certain outputs, so you can add a new attribute, a new field. Okay, for example, let's say that I have 5 or 6 polygon features. With these polygon features, I want to calculate the area of a polygon. Okay, so I'll add a new column that is called area. With that column, I'll start with another field calculator. I'll calculate the area. It is just like this, $area, like you do in your Excel sheet. So it basically calculates the area of this polygon. Only thing is that it can calculate the geometrical shape of based on the geometrical shape, it can calculate the value. So using that geometrical shape, it will provide me the area of that entire column. So all the 5 with just one stroke. So that is why you need a new field and a new field calculator in this attribute operation. So this gives you the entire attribute data editing in your database. So in case you want to edit your data, most of the operations on any of the databases is through attribute data editing. So this is extremely important in terms of you understanding, and most importantly, I would suggest, if in case you have already installed QGIS, please go through this field calculator. Field calculator is extremely very good tool for any kind of analysis that you want to make in the GIS platform. So it can provide you a lot of inputs and lot of extensive reporting and field data computations. Okay, the next thing is using QGIS as a processing toolbox. So nowadays it is the R as a statistical software and also an image processing toolbox has actually come up in a very larger context. R has extreme computational capability in terms of analyzing, in terms of statistical analysis, and also now in geometric analysis as over a period of time. Now in last 2-3 years, there has been huge number of research papers which is employing statistical software R as in both statistical and also as image processing package. So when you want to in case you want to integrate R with QGIS, we have to form much more extensive or strong tool in terms of statistics and in terms of image processing capability. So you can also enable R in this particular package. So if you just go into processing options in your QGIS, so you can click on that as R script and you can activate it. Once you have activated it, you can even use a 64-bit version in case your Windows is a 64-bit or your Unix or Linux is in a 64-bit version. So click on this so that R is linked. Once the R is linked, you have the entire toolbox of R that will come into your QGIS. Once this is done, any kind of statistical analysis can be done, and even the scripting in R can be done using this particular package. Now with the newer version, you also have WX Python and R integrated. So with this, the entire package of extensive good GIS software has been quite easily available in case you guys are looking at it. Okay, so R scripts and GIS integration. R scripts is processing spatial data processing framework for QGIS plugin. That's for R scripts. Needs to be enabled in the processing menu providers menu. After R is enabled, you can run the scripts from the processing toolbox as I have shown here. Okay. Now there is another feature of integrating the spatial database, that is through Spatial Light. So again, this can be enabled you can search it as a plugin and enable the Spatial Light feature. Spatial Light is a spatial database management system on SQLite. Okay, it is extremely lightweight and portable. Okay, raster tools include rasterlite. So you have both vector processing tools and a raster processing tools. If you look at it, it is when you look at it, you have all of the tools that the spatial light can handle, starting from geometry to the vector layers to spatial indexing, and also spatial index, and also to your raster indexing. So all of these can run, and it can handle SQL in extremely efficient way, SQL queries. Then you have PostGIS, which is the norm of the day. Most of the spatial databases run on PostGIS today, and when you are looking at this, QGIS is quite very efficient in handling PostGIS as a special database, and PostGIS database management can handle the entire database management of the QGIS. PostGIS is a GIS based extension for PostgreSQL. Okay, PostgreSQL add support for geographic objects to PostgreSQL, which means that PostGIS is one which gives you the geometric aspects or the geographical aspects to the main database system. Okay, that is nothing but PostgreSQL. Enables PostgreSQL server to be used as a backend server special database for GIS. Okay, so yeah, without PostGIS, it is not possible to use PostGIS only for your as a GIS tool, but as a GIS database, but it has to be connected to PostGIS, so that PostGIS provides the geometric output or the geographical nature, whereas PostgreSQL provides you the database. So spatial operations analysis simply mean running an SQL query in the database. So that is through the SQL operation itself. When you look at the entire PostGIS functions, you have functions that is starting from any of those functions are covered by within and maximum distance, longest line. So all of these are PostGIS functions that you can see. So if you just open the functions tab in PostGIS, if you go into PostGIS and see the open, look at the open tab, you can look at all of these functions. Then the next thing is pgadmin. This is a GUI base for database administration tool. So when you are looking at previous versions of QGIS, maybe even before 1.80, so most of them were in terms of coding. So but now we have a GUIS base for database administration. So if you look at this is a pgadmin tool, where you can see this is why this was one from this has been adapted from TerraGIS. So this particular screen, if you look at it, there are three different servers that are running, that is Snuggle, there is TerraGIS and other server. So out of which a particular TerraGIS server is running at a database which has a GIS data, map bender, then you have certain schemas and replication, and you have PostGIS running. Okay, so when you look at this, what are the data that are public are, it has conversions, it has functions, it has trigger functions. So these are different public. So you can make it public, it can be made as private. So that's based on the owner. It gives you the entire description of what it basically is, whether it has been inherited as a table, or it inherits any table from any other this one, what is a primary key in this particular table, and it gives you the entire property in case you are looking at how it has to be done, how it has to be coded, this how it is coded. Then you have statistics, depends and referenced by. So all of these are with the pgadmin. So one who wants to look at administration of the database as a tool, so pgadmin can be very useful in terms of administration. So again this was one of the things that was also explained by TerraGIS, that is a QGIS and Python interface. Python is growing as an extensively very good coding tool. So now QGIS also has come up with a Python console, which can handle effectively most of the Python packages and commands. So when you look at this, there are three options. One is the Python console, which is shown here. So it is just typing the commands and extracting the tools. Then you have processing toolbox. This is the entire toolbox. You have refer to toolbox, that's for image analysis, that is for geoalgorithms. Then you have GraphGIS. GraphGIS is extensively very good software for raster analysis. In fact, I would say that GraphGIS is one of the best software for raster analysis, as QGIS is for the vector analysis. Okay, and you have entire package of GDAL. GDAL, see, when you look at the difference, very basic difference between an open source software and the software that is licensed or proprietary. In the very basic, both of them run on, most of the GIS software run on GDAL or OGR. GDAL is a raster processing package and OGR is a vector processing package. When you look at this, these two packages, the way the proprietary software is that they define different tools, or they build different tools for usages, and you have a very intuitive and very nice GUI which is present in this particular interfaces. Otherwise, I don't see much difference from an open source QGIS software with an ArcGIS engine, though they have a lot of services, they have a backend support, though which is much faster and much easier. So that's all is the difference in ArcGIS and QGIS. But when you look at it, the same toolboxes can be accessed with this using Python console. Then you have, so you can connect it to Saga. Saga also has a huge collection of algorithms, and you can connect it to R scripts, etc. So these are different things that you can explore when in case you want to be an advanced GIS user using QGIS. So then you have tools such as WinPython and plugin builder. Plugin builder is one such tool wherein you can start building plugins for a particular applications. So in summary, we looked at what is logical consistency mean, how do you have to maintain a logical consistency. Then procedures in integrated data analysis, we looked at what are different procedures, how do we look at procedural inputs to GIS. Then basic operations in QGIS, how we'll do it. Then we looked at SQLite, PostGIS, then PGAdmin, etc. So finally we ended with PostGIS and PGAdmin. So these are different aspects, and also I would like students to explore with Python console and R as an input to GIS. Once we start the lab, so probably once we show you the basic of how QGIS works, probably you can start learning by yourself how you can attach Python and R and make it a powerful tool in terms of applications for your varied applications that you may have. Until next class, I will meet you in the next class with advanced analysis, advanced data modeling analysis. So that would be the probably the last class of theory that I would take up, the last module of theory. The rest would be more on practicals, and finally it would the course would end with more of what do you mean by various standards, how are standards maintained, and is there any standards that we have to maintain when you are creating data and sharing data. So we would end the course with that, but in the next class I would take up the advanced tools or advanced modeling to advanced tools or special analysis tools in GIS. Okay, so until then, have a nice time. Thank you very much.